Here we have a contractor. He combines X tons of gravel mixture that contains 10% gravel by weight. So maybe 10% was gravel, the other 90% was maybe sand. And then he combines that with Y tons of a mixture that is 2% gravel by weight. So again, this would be maybe 2% gravel and 98% sand. And he produces 80 tons of a mixture that is 5% gravel. So we need to solve for X and Y. So here we've stated the variables. Okay, X is the tons of the 10%, Y is the tons of the 2%. So we need to come up with a system of equations here. The first equation is going to be fairly straightforward. We know that these two tons, these two amounts, add up to 80 tons. Okay, so the tons of X, tons of Y equals 80 tons. Again, make sure that's consistent. Our units are consistent. Yeah, tons equals tons. So the second equation, how are we going to do this? We need to involve the percentage. So what we can do is we can figure out the total amount of gravel and make an equation for the total amount of gravel. So I'm going to take 80 tons of gravel and times it by 10%. Sorry, 80 tons of mixture and times it by 5%. And I'm going to get the amount of gravel. So if I do 0.05 times 80 tons, this works out to be, that's going to be 4 tons of gravel. Okay, so this is 4 tons, and this is, we're talking about pure gravel now. So what's that going to equal to? Well, we need to figure out the amount of gravel that we got from the 10%. So that's going to be 0.10 times the amount from the 10% plus 0.02 times the amount that we had at 2%. So this is going to be the tons at 10%, and this is the tons from 2%. Okay, so this is what equation looks like. We have tons equals tons plus tons. So here we work out to be 4 is equal to 0.10x plus 0.02y. Now we want to get rid of one of these variables, so we're going to use this other equation here. And maybe we'll just get rid of the y. So we'll isolate the y and we'll plug that into our system of equations. So we end up with 4 is equal to 0.10x plus 0.02, and instead of y, I'm going to replace that with an x expression, 80 minus x. And there we have our equation with one variable. We can go ahead and solve this. 0.10x plus, that's going to be, looks like that's going to be 0.16, no wait a minute, 1.6 minus 0.02x. So I end up with, I'm going to move this over to the other side here, so we're going to end up with 2.4. So subtract 1.6 from both sides. Here I'm going to go 10% minus 2% is going to give me 8%. Solving for x. Okay, so I'm going to end up with, looks like 30 in this case. 30 tons. Okay, which makes then the y amount is equal to 50 tons. Okay, so I have 50 tons of 2% and 30 tons of, in this case, what was it again? 10%. Okay. Now, I want to show how we can, since this is a percentages and proportions, I just want to show you what this looked like if I drew this out. So let's say I have 2% and I have 10%. and I wanted to get 5%. So 5% would work out to be right about here. So these are my percentages, and I can break this into 3 parts and 5 parts. And notice that when I do this kind of spacing, that the 30 tons and 50 tons are actually connected to this. I needed to get it, maybe I'll draw this a little bit better, I need to move it more over to this side. So I needed more of the 2%, so I use 50, so notice that I'm just using the opposite. I use 5 parts of the 2%, 3 parts of the 10%, and this relationship seems to hold true. This proportion in here actually reflects the proportion, but in reverse, of the amount we needed for 2% and 5%. And this is not by coincidence. This proportion, this spacing in here actually gives us an indication of the proportions as well.